Hi, fifth graders, it's Mrs. Clark. Welcome to our second lesson in Unit 8 on geometry. A reminder that our table of contents includes the lesson we already did on the introduction of exploring and measuring angles. Today we're going to talk about triangles, and next we'll have transformations, investigating, subdividing, and combining figures, and finally we will talk about circles. Make sure that you have your notes with you in your notebook and you're ready to get started, that I have your full attention. If you ever need to pause the video to catch up on your notes, make sure you do that, and you can always go back and review the videos as many times as you need to help you practice. So let's get started. Today we're talking about triangles. By the end of this lesson, you should be able to classify triangles as right, acute, or obtuse, and equilateral, scalene, or isosceles. You'll be able to investigate the sum of the interior angles of a triangle and determine an unknown angle measurement. So let's talk about some types of triangles. Triangles can be classified or grouped by their sides. And we're going to talk about the three different ways that we can classify or group triangles by their sides. First, we have the equilateral triangle. The equilateral triangle gets its name from its equal sides. Equal sides, equilateral triangle. All three sides of the triangle are the same length. And we note that there in the picture with those hash marks, those lines on the sides of the triangle. Since each side has the same line, it notes that this triangle's sides are all equal. So even if you don't know exactly how many inches or centimeters the triangle sides are, you know that they are equal because they have the same hash marks on each side. Next, we have the isosceles triangle. This triangle has two equal sides. And you can see in the picture that it has two sides labeled with the same hash mark, and then the third side doesn't have a hash mark. That's because the third side is a different length than the two sides noted there with the hash marks. So an isosceles triangle has two sides that are the same length. Then we have this scalene triangle. This triangle does not have any equal sides. All three sides are different. And that's why in the picture you can see that each of the sides of this triangle has different hash marks. One of them has 1, then 2, then 3, noting that all three sides of this triangle are different lengths. You can also classify triangles based on their angles. So we're going to talk a little bit about the ways that you can classify triangles based on their angles. So first we have the acute triangle. The acute triangle is a triangle where all three angles inside the triangle are less than 90 degrees. These are acute angles, which we learned about in our previous lesson. So if your triangle has three angles less than 90 degrees, you can call it an acute triangle. Then we have the right triangle, which gets its name from its right angle. You will have a triangle that is a right angle if it includes a right angle that measures 90 degrees. And oftentimes, as we learned in the last lesson, the right angle will be noted with that square in the corner to show that it's 90 degrees. Then we have the obtuse triangle. This is a triangle that has an angle larger than 90 degrees, an obtuse angle. So anytime you see a triangle with an angle larger than 90, you can classify it as an obtuse triangle. So you can classify and group triangles by sides and angles, or you can combine it together and group them by their sides and their angles. So you can see in the three pictures here on this slide, the first triangle we can call an acute equilateral triangle because all three sides are equal and the three angles inside the triangle are all acute. The next picture is going to show an obtuse scalene triangle. It's scalene because all three sides are a different length, and it's obtuse because it has that large obtuse angle there at the top. Finally, on the right, we have a right isosceles triangle. A right triangle because it has a right angle that measures 90 degrees, and isosceles because it has two sides that are of equal length, noted there with the hash marks on the sides. What happens if we're missing the inside angle? Well, just like with angles, we can solve for missing angles inside triangles. The three angles inside a triangle will always add up to equal 180 degrees. Always. Triangles interior angles equal 180 degrees. So if you're missing one of the angles, you can do a little addition and subtraction to solve for the missing angle because all three angles will always add up to equal 180 degrees. Well, that's it for today's lesson. Today, we explored the different types of triangles and how you can group and classify triangles based upon their sides and their angles. And then we looked at the inside of a triangle and discovered that it equals 180 degrees and figured out how to do some addition and subtraction in order to figure out the missing interior angle inside a triangle. I hope you enjoyed the lesson. Make sure your notes are complete, and I'll see you in the next video.